We're going to finish up Chapter 7, Section 1 right now. So this is Chapter 7, Section 1. You can call it a Part B if you want to. But this one is going to be about molecular nomenclature, and that will include acids. It will include acids. So with molecular nomenclature, we are going to use a prefix system. Besides the acids, we're going to try to concentrate on binary compounds. The prefix bi means two. So these are going to be compounds that have two elements in them. And your less electronegative atom comes first. If you recall our molecular compounds, they are going to typically contain two nonmetals. If you go back and you look at your periodic table, figure out where your nonmetals are at. That also includes hydrogen there. Hydrogen is going to be in all of our acids, but those nonmetals, we're going to be pairing those together. The less electronegative atom comes first. We're going to add prefixes to indicate the number of atoms, and the number of atoms will be those subscripted numbers we'll work with. One little extra piece in there, the mono prefix, and we'll look at all 10 we're going to have to know. Omit the mono prefix if it's on the first element. So in other words, if your first element only has one atom, you will not add the mono prefix. And we change the ending of the second element to ide, I-D-E. And there's just a quick recap on electronegativities. Again, electronegativities, your larger electronegativities are going to be right over here because fluorine is the most electronegative element. And in general, your smaller electronegativities are going to be at the bottom of group 1. There are the 10 prefixes you need to know: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Please write those down in your notes, and you will need to know those. I know that there's other prefixes for mono, such as uno, or for di, such as bi, and so on, but make sure you have those 10 prefixes down for our molecular nomenclature. And we'll get started with some examples. CCl4, again, it is a binary compound. There's only two elements, and those elements are carbon and chlorine. So carbon is the first one. There is only one atom of it, because again, it's an understood one that's right there. You drop the mono prefix. But with our chlorine, there are 4 of them. So the prefix for 4 is tetra. And instead of writing chlorine, we said we changed the ending of the second element to ide, so it's tetrachloride. So our prefix, IDE ending, there you go, carbon tetrachloride. For the next one, we have 2 nitrogen atoms. So for the number 2, the prefix is di. And you just write down the element name, which is nitrogen. And for the last part, there is only one oxygen atom, because that's an understood one subscript. So you have to use the mono prefix. So instead of monooxygen, you change the ending to ide, so it's monoxide. Notice right here, we didn't write monooxide, so there's not 2 O's together. Really common if your element starts with a vowel, then you drop the vowel that is at the end of the prefix. So oxygen is going to be your most common one. And for our last example, there is only one sulfur right here, so we just write sulfur. But there are 6 fluorine atoms. Oops. So our prefix for 6 is hexa. And instead of writing fluorine, we drop the ending and write fluoride. So sulfur hexafluoride. Please note that our first element is never going to end with ide. Okay? The first element never ends with ide. It might have a prefix, but do not change the ending of the first element. Only the second element. Okay, now moving back the other way, here's our names going to the formulas. Again, really easy if you've already got your formulas down, picking out some prefixes. No prefix there. I see tri, di, penta, tetra, deca. So all of those prefixes need to mean something. For arsenic, it's AS. There's only one because there's not a prefix. And then trichloride, the Cl for the chlorine with a 3. Dinitrogen, the 2 comes from the di, pentoxide. The 5 comes from the penta. And then tetraphosphorus, phosphorus, there's tetra, so that's 4. Oxide, deca is 10, so P4O10. Notice that going through molecular nomenclature is much simpler than ionic. We did absolutely nothing with charges. If you have your prefixes memorized, it's really easy to go back and forth with your prefixes. Now, another group of compounds that also fall under molecular nomenclature are the 7 diatomic elements. Hopefully remember those, but a way in which we had talked earlier, some people, the way it's listed here, say Brinkelhoff, just so that they can remember the 7 diatomic elements. But you do need to know what the 7 diatomic elements are. And these are a little different because if I were to ask you, well, what is the name for Br2? You're probably thinking, the most common answer I hear is dibromide. I also hear bromide, dibromine. But the answer for our diatomic elements, because we've stated they have to be attached to another atom. So if they're not attached to something else, they will attach to themselves. So it is simply the name unchanged of the element. So Br2 is bromine. H2 is hydrogen. F2 is fluorine, since they are in their diatomic state. Here we are going to add on our acids and naming convention for acids. All of the acids we're going to deal with are considered molecular compounds, but they have their own special way in which they are to be named. So we're going to concentrate first on the anion side of things. And as you recall, anions have a negative charge. The anions that we are looking at are either end in "-ide", which are your monatomic anions, a few of your polyatomic anions, but we're concentrating here. If we say "-ide", it's going to be your monatomic anions. And then we've also got, from the polyatomic side of things, "-ate" and "-ite" are the 2 most common ones. So if you have those anions, what do you do with those when you come up with the acid name? Well, if your monatomic anion obviously ends in "-ides", then the acid starts with the prefix hydro, ends with "-ic". So some examples as I'm looking at my monatomic ions: hydrofluoric, hydrochloric, hydrobromic acids, all of those follow that convention. Now moving on to our polyatomic ions ending in "-ite" and "-ate". If your polyatomic ion ends in "-ite", then the acid name ends in "-ous", us. And if it ends in "-ate", the acid will end in "-ic". So no prefix there unless the prefix is just part of the polyatomic ion. So getting started with this, we're going to go through a couple of examples. If I gave you the acid HF, and by the way, all acids contain hydrogen, and the majority of the time hydrogen is listed first. So that's going to be 95% of the time. So HF, it's a binary compound, only two elements, your H and your F. We're going with the first naming convention because the F here is fluoride, so it is hydro, fluor. Instead of "ide," we put our "ic" ending on there, hydrofluoric acid. And you'll have to do some playing with some of these because sometimes they don't drop some letters in the middles, and in this case they do drop some letters. Hopefully, just through living, you have heard several acid names, so go with what you think also sounds good. Another example down here, we're going to go the opposite direction, and we're going to start with sulfuric acid. And you give me the formula. So I go back and I look. Well, my acid has no prefix, but it does have that "ic" ending, which means I should be dealing with an anion that ends in 8. And that is the sulfate ion, because I'm also looking at the beginning of what's given. So, since it's the sulfate ion, SO4, and by the way, the sulfate ion itself has a 2- charge. We've already stated hydrogen's got to go at the beginning of this, but now we can kind of go back and think about, we need those charges to cancel, so how many hydrogen ions do you need to cancel with the sulfate ion? Well, sulfate's a 2-. Hydrogen is typically a 1+, which it definitely is in this case. So I need 2 hydrogen atoms so that it balances. I'm going to go ahead and erase charges. And there we go. 2 hydrogen. So H2SO4 is the final formula. If you go with that same logic and go back up and you look at HF, HF up here, hydrogen again a 1+, F is a 1-. Since those two charges automatically cancel, and I know I'm talking charges again, even though these are acids and we're supposed to be talking about molecular nomenclature, but it is a way to go back and double check. But the 1+, 1- do cancel. That's why you only see 1 atom of each. So there you go, a couple of examples of acids.